This is a summary of friction and how to use it in solving force problems. So here we have a 10 kilogram mass on a surface. In this case there will be friction, and we have a horizontal force of 40 newtons pushing on it. We need to determine what will happen. Will the box move or stay still? If it moves, what's its acceleration? So the first thing, as always, is to draw a free body diagram. So here's our mass. Our weight is 10 kilograms times 9.8 meters per second. So that's 98 newtons. We also have a vertical force, the normal force of the surface pushing up, and then I have a horizontal force of 40 newtons. And I have a frictional force opposing the horizontal motion. Don't know how big it is, but I do know it's going to oppose all the other forces acting on that object horizontally. In previous problems, in this situation where there's only N and W, we know that N equals W, so the normal force, that also is 98 newtons, Friction is proportional to the normal force. So there's two types of friction we're going to look at: static friction, and we can calculate the maximum available static friction in any situation. It's equal to a coefficient of static friction times the normal force. In our situation, let's assume that US equals 0.5 newtons, or 0.5, it's a unitless number, and let's assume mu k, the kinetic friction coefficient, is 0.3. I use these numbers often. They're just typical. Those values depend very much on what surfaces are being used. So back to this problem, then I have 98 newtons for my normal force. I have half of that, so that's 49 newtons of available static friction. Now it's important to note that this is the maximum available static friction. That doesn't mean that that's what the frictional force is. I can also calculate what is the kinetic friction. If the object does move, what will it do? And that would be mu k times n, which is 98 times 0.3. And so that would tell us how big the force is if the object actually was moving, and that's 29.4 newtons. Okay, so those are our two possible values of friction, or kind of gives us 2 points of information about friction. And what we can do then is now proceed forward and try and identify what's going on. In the x direction, F net x equals max. We have a situation where I've got 40 newtons pushing to the right minus friction equals max. Now, it's important to note that friction can never be stronger than the applied force. So in this situation we have 40 newtons of force. If we compare that 40 newtons to the maximum available static friction, which is 49 newtons, we realize that this horizontal force is not sufficient to overcome friction. So in that situation, my acceleration is 0 because it doesn't move. Then I can solve for friction, and F is in the negative direction. It actually is equal to 40 newtons. Okay. So in this case, there's a situation where there's a heavy object that I'm pushing on. friction is so strong that it doesn't move, and that object pushes back on me with the same force I push on it, 40 newtons. What happens though if we change our force to 50 newtons? Then I have 50 newtons is greater than 49, so the object actually is going to accelerate, and my friction would then be kinetic because the object is moving, and that equals max. So in this case, ax equals 50 newtons minus 29.4 divided by 10 kilograms. So that's 2.06 meters per second squared. Okay, so let's review what's going on here. In this situation, I've got a 50 Newton force, which is only 1 Newton stronger than the available maximum static friction. So the object has just enough, is being pushed just enough to get it moving. Once it moves, it's skipping along the surface, and the available friction from kinetic friction is 29.4. So I have 50 newtons of push minus 20.4 newtons of kinetic friction, and I can use those to solve for acceleration. So in summary, what we have to do is compare the maximum available static friction, Fs max, which is mu s times n, compare that to all the other forces in that direction, sum those up. If the net force of all those other forces is more than Fs max, then the object moves and it's opposed with kinetic friction. If, on the other hand, all those other forces add up to less than Fx max, then Fs, the static friction, pushes back on those with the same amount as those are pushing on the object. Hopefully that's clear.